Hi, good afternoon. My name is Chih-Hsuan Wei from National Library of Medicine. Today, I would like to share our recent research for relation interaction with directionality information. This is a well-known pipeline for extracting the knowledge in literature. Given the list of articles from PubMed or PMC full text, the first step is to recognize the entities by NER methods. The next step is to map those entities to a specific concept identifier like a gene to NCBI gene accession number. And with those information, we are able to extract the relation between the entities. With those entities, we can build the knowledge graph or for downstream text mining research like knowledge discovery or question answering. However, existing relation extraction datasets are mostly focusing on the sentence level, which means the two entities co-occur in the same sentence. And mostly those datasets are normalized, not mapped to a specific concepts. And even though there are few datasets that focusing on the document level, which means the two entities can cross different sentences, and those datasets only focusing on specific relation type. For example, like the chemical-induced disease in BC5-CDR corpus. Thus, we need a corpus that can cover most of the entities and can cross the sentences. And this is an example on the right that tells the document, an example of the document level relation extraction. The title has the disease and the associated genes. And also the middle of the sentence, middle of the abstract telling the causal disease, the causal variant of the disease. And the discussion telling the abnormal metabolism described in the last sentence of the abstract. That's very difficult for relation extraction if those entities are very far from each other. So there is a current relation extraction stage is BioRed task in BC5 in BioCreative 8 that try to extract the relations between the entities among disease, gene, chemical, and others, and covering the relation pairs among those, and with 8 relation types, including positive, negative, association, binding, and others, and also the data sets annotate the novelty. However, we observe that the directionality of the relation doesn't annotate in the BioRed. And here is an example to tell that there are the B55, B53, and MDM2, the two genes. There are two genes proteins. Actually, we consider the name interchangeable, so they bind to each other, but with different functional mechanisms. That's lead a very big challenge to the downstream text mining research, and thus we would like to do something to recognize the object and subject of the relation to make it clear. And based on that, we build a tool named BioRedirect, which is a multitask directional relation extraction method. In addition to the relation type and novelty annotated in BioRed, we also annotate the relation, the directionality. And this is an example from the variant to the disease. We annotate that is a positive relation and with a novelty findings. And also that is a rightward relation from variant to disease, because that is a causal variant to the disease. And we annotate the 600 abstract, and we upgrade the BioRed corpus with the directionality for 600 abstract for training and 400 for testing, covering 12,000 relations. And among those, there is a 10,000 relations with directionality. We have 2 curators work together to work on to annotate that, and with 50 randomly selected articles overlapping. And our annotator agreement is almost 90%. Okay, this is the pipeline of the bioredirect. The input is the text with the highlighted entities, and we collect all the candidate pairs between entities. For each pair, we follow the predefined input representation to prepare the input to put into the pre-trained model, and collect the maximum pooling of the tag from the relation type, directionality, and novelty together into the joint task learning. The contribution of the work covering those, and this is the first document level relation interaction with directionality. And actually, we also applied a segmentation method to fully utilize the context, because the method we expect not only be applied on abstract, but also can be applied in the full text. So some of the paragraph can be extremely longer. And also we apply hard and soft prompt to enhance the performance of the relation interaction, and do a joint my task learning to extract the relation, novelty, and directionality simultaneously. And this is the input representation. In front the input text, that we add a hard prompt, which is a question asking the task of asking the challenge of the task, and also providing the pair of the entities. And in the end of the input text, we use the soft prompt, which is the learnable embeddings, unlike the hard prompt, which is a fixed text templates. A soft prompt is optimized during the training. And here is give you an example how the segmentation strategy do. We firstly use the prefix to be the first trunk, and use the second, the suffix part to be the second trunk, and use all the median sentences window containing the two entities to the infix trunk. And this is the loss function, which is the summarization of the loss, of the average loss of the relation type, novelty, and directionality, and with a learnable weight. We evaluate our methods on BioRed corpus in BioCreative 8, and also the BC5 CDR corpus. BioRed corpus contain 500 articles for training, and 100 for development, and 400 for testing, including 8 relation types, covering 12,000 relations. Among those, 10,000 are with directionality. However, the BC5 CDR corpus has 1,500 articles. However, no directionality was provided, even though all the relations are already presented by chemical-induced disease. So we compare our method, which is bioredirect, with some other deep learning-based method, including PalmBird, BioRex, and also the fine-tune and zero-shot learning model for GPT 3.5, 4, and Llama 3.2. In the fine-tune large language model, this is the prompt we use to fine-tune the model, and given the prompt to tell the large language model the entity pairs to be considered, and also we give the content with the highlighted entities. The output will be a JSON format with the three components containing the results of the relation labels, directionality, and novelty at once. And this is the results showing that we evaluate on BioRed corpus that we obtain statistically significant than all other methods, including the large language model and the transformer-based approach. And especially that we have much better performance on directionality than others. However, considering all the tasks together, the performance dropped significantly from 75 to 37%, which demonstrates this is still a very hard task. And we also evaluate our method on BC5 CDR and represent a higher performance than all others, even though GPT 3.5 has a higher recall. Our method still presents balanced performance. Many of the researchers also will be argue that why not just use a larger entry model directly to the articles to extract the relations. And actually, the common answer is the cost, because if we would like to apply them on a large scale like PubMed or NHRPMC, that would be a challenge. And we also evaluate our method to see the performance of the segmentation strategy, comparing the performance with all chunks and the models with individual chunk, and shows a significant improvement. We also evaluate the performance on a soft prompt and also compare the performance of the single task and the multi-task, and both contribute and don't demonstrate that those modules contribute to the performance. And we evaluate the results, and here's a quick figure to illustrate that some of the tasks, some of the entity pairs is still very hard to deal with, which is association sometimes is still very confusing to other relation types. Sorry, I just realized. Okay. Did I this?
No, I think something happened to the...
Oh, okay. So did I describe this slides, or did you see this? Yeah. Yes. Okay. So this is the slide that missed. Okay. We did an evaluation on, we did an analysis on the results, and showing that association is the hardest part, because many of the relations are recognized and confusing to other relation type, like the positive or negatives. And this is conclusion. We reach Bio-Red with 10,000 relation types or relations with directionalities, and we demonstrate the performance of the multitask learning segmentation strategies and soft prompts. And also we perform much better performance than other methods in Bio-Red and BC5 CDR datasets. In the future, we will collect more instances from existing datasets from their pairs with lower performance, especially those entity pairs like the binding that we not get better results, and also apply Bio-Redirect for downstream text mining research like knowledge discovery. And thank you for your attention, and any questions.
Thank you so much. Do we have any questions? Yes.
Thank you for the great presentation. I was curious to hear if you considered using SEMREP as another benchmark tool. So this is a tool from the 3 transformer games, and it returns subject, predicate, object triples. So you implicitly have directionality in that representation. Have you considered this?
Yeah. Yes. We didn't do the comparison, but we do comparison before on Bio-Red corpus paper, because the SIMREP is more focusing on because the entity recognized by SIMREP is by dictionary base, and actually the backend of the entity recognition and relation extraction is binded. They cannot be separately to be evaluated in SIMREP. So it's hard to compare the performance. But yeah, it is worth to give a try in directionality. Yes, agree with that.
Thank you.
Any other questions? I have a question.
Yeah, sure.
So you saw the results and you saw the association expectedly was the worst class to predict. How were the annotators doing with it? Because I remember, like, when we were annotating another corpus, actually, like for regulation, which is a similarly general class, we actually had issues as annotators to agree what to annotate and when something is regulation. And I remember that was where we spent most of our times disagreeing.
Yeah.
So how was it for you?
Yeah, actually, that is the same. But the problem why association confused to other types is because association is the major part, is the major relation types. So everything that model cannot be make a decision. Mostly it come to the association. So it is the error is not because the association itself. It's because other relation types that cannot be dealt with that very well, like a binding. Binding is like there is a relation which is called a co-treatment between two drugs can co-treat the same disease, and the relation is frequently be mistakenly mapped to the association because the training set is only about 15 records. Yeah.
Good. I don't see any other hands, so let's give a round of applause again.
Thank you.